This is CPM Precalculus Chapter 3, number 107. Evaluate the following log expressions without a calculator. Alright, so part A, we have log base 3 of 81. Okay, so we can rewrite this as log base 3 of 81 equals to something like x, right? And we can go ahead and convert this into an equivalent exponential equation by taking 3 to the power of x, right? I'm just taking the base 3 to the raise to the power of x equals to 81. Because when you read log base 3 of 81, you know that this is asking you what power do you raise 3 to get to equal to 81, right? And this is what I just said right there. What power do you raise 3 to x to get to 81? So now this is just a little bit of checking. Well, 3 times 3 times 3, how many times do you have to multiply it by itself to get 81? Okay, so you might need to do a little checking. 3 times 3 we know is 9. Times 3 again is, well, 9 times 3 is 27. Times 3 again, well, that equals to 81. So 4 3's, 3 to the 4 is equal to 81. Therefore, x is equal to 81, right? Our x, no, not 81, sorry. Therefore, x is equal to 4, right? Therefore, this expression here is equal to x, or we can just go ahead and say is equal to, I'm going to erase x and say is equal to 4. Okay? Part B. Part B, we could start the same way. We can go ahead and say, well, let's say it's equal to x for now. That means we can rewrite this as an exponential using the definition of a logarithm. 5 to the power of x is equal to square root of 5. Well, we know that square root is the same as 5 to the power of 1/2, right? Because this is just a fractional exponent representing the square root. That means x is equal to 1/2, right? And again, that means that I could go ahead and say it from the beginning. Instead of x, I don't even need an x. I can just say log base 5 of square root of 5 is equal to 1/2. Finally, C. C again, I can start off by giving it some variable value. Then I know that means the base raised to that variable value is equal to what we're taking the log of, 1 over 16. Okay, so this might be a little tricky, but we can just go ahead and convert this to have the same base of 4 like we've done in the past, right? This means 4 to the x is equal to, well, 16 is just 4 squared, right? We can move this to the numerator by negating the exponent. So this is 4 to the negative 2 is equal to 4 to the x, right? I'm just keeping the left side the same, simplifying the right. That means the exponents are equal. X is equal to negative 2. And I'm able to erase the x here and put equals to negative 2. In fact, I can even leave x here and say, well, that's equal to negative 2. Because this whole thing, I'm just having equal signs. And the answer is negative 2 for part C. So that ends for us CPM Precalculus Chapter 3, number 107.